So GeoTrig, this is lesson 30. We're going to talk about adding vectors, and vectors, guys, are just polar form. Polar form and rectangular form. So you guys have seen this before. And so what we're going to have to do is switch from one form to the other and back. So I'm hoping that this actually goes a little bit easier, a little bit quicker for you, because we've been dealing with sine, cosine, and tangents and working with that a little bit more. There are two different words now that we're going to have to deal with. One's called the resultant. The resultant is just combining two vectors together by adding. So basically, adding the two vectors together. And you guys have done that already. When I asked you to add two polar forms together, you converted them to rectangular, I hat and j hat, and then added the I hats together, the j hats together, and then put it back to polar form. So that you've already been doing. So the word for that is resultant. Find the resultant. Basically, add them together. The equilibrant, though, the equilibrant is a single force that would be required to negate the applied force. It's the opposite way. So if I'm pushing something with the force of 2 newtons, that means the equilibrant would be someone pushing me back 2 newtons, right? Now, saying that, the equilibrant is the same magnitude, so that number on the outside of that little bracket thing is the same, but it has to go in the opposite direction, which means it differs by 180. So if I'm pushing something or going 0 degrees out 5, the equilibrant would be 180 degrees going out 5. They differ by 180. Now, that's very kind of important here is the fact that if you're given two different vectors that differ by 180 degrees, you don't even have to go to rectangular form. You can just do everything right in polar form, and it makes it way easier. But you have to recognize that. So, hence, if I did something like 3 going 25 degrees, and I added 4 at 25 degrees. Think of it this way. That's the same direction, isn't it? 25 degrees? So if one's going to move you 3, the other one's going to move you 4, then our complete movement, am I going to actually change the angle? No. The angle will be the same. How far will I go, though? 7. So that same idea, I don't have to go to rectangular form. Remember, in rectangular form, I'd have to draw a picture for each one of those, right? Draw a picture, go 25 degrees, and go out 3. Yes? And then I'd have to figure out, using my triangle, I'd have to figure out my I hat and j hat, using sine and cosine. I don't have to do that here, if they're the same angle. Now, I can use that same idea. What if I said something like 4 at, say, 45 degrees, plus 6 at what would be 180 degrees difference from this?
45.
You're already going 45. Where's 180 degrees difference? 225.
Nice.
225, remember, 45 is here. 225 is down here.
Did you do 360 minus 45?
I just did 180.
I added 180 to 45, or that's what Adam did. So what we're doing, guys, is we're pulling this force in the exact opposite directions. If I'm playing tug-of-war, right, if you think about it, this rope here will be down here. So it looks like one continuous vector, but one part's pulling it one way, one part's pulling it the other way. The one with the stronger force will win, right? So which one has the stronger force?
6.
The 6. By how much?
180.
By 2. Right? 4 or 6. So the 6 has a bigger force. So therefore, the overall would be 2 in which direction? 225. Wait a minute. This all goes back to that whole idea of how many polar forms are there? 4. Could I have also said that that was a negative force in which direction? At 45? Because if I only turn 45, the guy who's at 45 gets pulled back 2 spots. You remember that? Kind of visually, isn't that? If I'm doing that tug of war idea. So, the first thing what I'm going to start to do now, because the book's going to start to trick us, is that they're going to give us vectors that differ by 180. So you don't have to do all this extra work. Could you? Yeah, it'll still work out. Okay? So, let's start off with these ones here. Find the resultant. 4 at 20 degrees plus 7 of negative 2/3. So the first thing you probably are going to check, bless you, are they, or do they differ by 180 degrees? If I add 180 to 20, I'm at 200. So therefore they're not. So that means we have to switch them to rectangular. So graph each one. That was part of our deal last time we did this. So if you need to, go back to those steps. We're going to talk about them today. If you need to write them down again, go back to that lesson. 20 degrees is here. I form a triangle with the x-axis, always to the x-axis. And I have a radius of 4. Find x and y. That should be no problem nowadays with the fact that x and y, wait a minute, you can almost think of it as the unit circle in a way. X is your cosine and y is your sine. And so, if I want to find x, I use cosine. If I want to find y, I use sine. Cosine 20 equals what? X over 4. Or x is equal to 4 cosine 20. Just multiply both sides by 4. Sine, I need to use sine. Sine of 20 is equal to y over 4, or y is equal to sine of, or not sine, but 4 times sine of 20. Take your calculators out, figure those out. Make sure you are in degrees, because that's what we're in. What is 4 times cosine of 20?
Wait, no. 3.75 or like 3.8.
3.75?
Yeah, that's good.
76? I'll go with 7.6. I'm okay with that. Okay. 4 sine 20? 1.36. Okay. So, what does it look like in I hat and j hat form? 3.76 I hat plus 1.36 j hat. That would be our rectangular form of the first vector.
We're done?
No, we got to do the other vector, and then we have to add them. Guys, we've done this already.
No, we're not. Pretty sure we haven't. Yeah.
Now we need to do the same thing with the 7 with the negative 230 degree turn. Remember, negative angles go down. So therefore, that's 180. So 130 will be somewhere about here, right? That's a negative 230 degree angle. And I'm walking out a positive 7, so my radius is 7. We formed that triangle, but what's the angle then formed? Well, how many degrees is going that straight line?
180.
180. So
50.
from 180 to 230 is
Oh no, 50. Yeah.
50. So 50 is my reference angle. So using the same reasoning as before, I have x and I have y, and hey, y actually works out for both of them. I'm going to leave that original y there. X, though, is going to be what? What's x going to be?
Cosine.
X is the cosine, but what is it going to be overall? It's going backwards.
Negative.
So it's going to be negative. We have to put that on after. So cosine of 50 is equal to x over 7, or x is equal to 7
Cosine
50. Because the angle is 50 degrees, it's a reference angle to negative 230. So sine of 50 is equal to y over 7, or y is equal to 7 sine of 50. Each one of these will have its own value. So what do we have for the 7 times the cosine of 50? What do we have? Negative 4.4? 4.491? 4.49 then? And 7 sine 50 is a positive 5.36. So that means a negative 4.49 I hat plus 5.36 j hat. So this is exactly everything separately we've done before, and we looked it up. It's lesson 14. The difference for today is that I am going to put parentheses around each one of these now and add them together. That's the new stuff. Resultant means add them together. Well, guess what? I hats are like terms. J hats are like terms. So what does that mean? It means that 3.76 plus a negative 4.49 I hat plus 1.36 plus 5.36 j hat. I'm just adding the I parts together, the j parts together, or the x's and the y's. That forms a new point. Yeah. So what do we get when we subtract or add the negative 4.49? Negative 0.73 I hat plus 6.72 j hat. So again, if I wanted to find out where this vector was, negative, just really quick graphs here, right? 1, 2, 3, 4, 5, 6. I would have to go somewhere almost 1, 2, 3, 4, 5, 6, 7. It's there. Because it's a negative 0.73, so it's back just a little bit and then goes up.
You didn't graph the negative 3.4.
Yeah, that's here. It forms this little triangle here. So what we want to do now is put it back to polar form, which means I have to find r, the radius, how far do they combine together to move, and the angle. It's in the second quadrant. And to do that, you have to put your 6.72 and your negative 0.73 on your triangle. To find the radius, You just use Pythagorean's theorem. Everyone should know. X squared plus y squared equals r squared, or a squared plus b squared equals c squared. So 0.73 negative squared plus 6.72 squared is equal to r squared. To save a little bit of time and space, someone square that negative 0.73, square 6.72, and add them together for me. We all should be able to handle this on a calculator by now. What's that?
I was just wondering if anyone would.
So we get 45.67 square root. The radius should be what? Just under 7. So 6 point what?
6.75.
75. Notice that it's actually a little bit larger than actually smaller than the largest magnitude, but it's definitely bigger than the 4. So it's somewhere between 4 and 7. So in this case, because there was enough action going to the side that you weren't able to go straight up, we kind of lose a little bit of the force of that magnitude. Yep, we're going back to polar. Now we have to find theta. And how do we find theta? Taking the inverse tangent. Because tangent is the opposite over adjacent. So that would be 6.72 over, and I'm just going to drop the negative because it really doesn't matter. What is the inverse tangent, make sure you're in degrees, of 6.72 divided by 0.73? 100. What's that? 9.2 degrees. Is that the angle that we're actually going to use in our problem? What is 9.2? It's theta, or the reference, right? How many degrees does it really take to get there, though? 180 minus. It's wrong?
I just did it.
Oh. Okay, hold on. Oh, let's say that does seem a little low. What does it end up being? 83.8. Okay, I'll change it. So that changes it. Definitely is not 170. What is 180 minus the 83.8? 97 or 96? 96. Careful. 96.2. So, if I want it to be in polar form, I know it's starting to get messy. We're getting a little mixed up in here. I'm going to run out 6.75 at how far? 96.2. That would be where the vector would take us to get directly to the spot of the accident, we'll say. When those forces combine, that's the resultant in green there. Okay, we're going to do this one, and it should go a lot quicker. So, find the equilibrant. What does that mean, though?
Find them added together in terms of 180.
Put them together, keep the same magnitude, and then at the end, take your angle and differ it by 180. And that's it. Do exactly what we just did, but at the very end, instead of, I'm going to go back, so instead of having 96.2, I'm just going to add 180 to it, and that'd be the angle. Right, because that'd be the equilibrant, that'd be in the exact opposite direction, pulling it in the opposite direction. Okay, so start this problem, and then we're going to join together. I quickly jotted down a quick graph for each one of these. The second one, notice that it's a negative radius, so I'm actually going to go backwards And the reference angle is 10 because if you go 170 degrees on your top arc, which leaves you 10, and then they're vertical angles, remember. So now we're going to quickly go through this. Now, wait a minute. It seems like every time I do my sine and cosine, all it was the radius times the cosine of the angle. Or it was the radius times the sine of the angle, right? So I had to multiply both sides by the radius. So if x is the cosine part, isn't that just 4 cosine 50? Y is 4 sine 50. Just make it go a little bit quicker for us. Taking your calculators out, work on that. X equals 6 cosine of 10. Y is 6 sine of 10. Should be going a lot quicker. Second time through with a different problem, same stuff. 2.57 for cosine. Not yet. When we put it to our point, we're just figuring out x and y are right now. So then 50 sine times 4 is 3.06. And 10 cosine times 6 is 5.91. And the last one, just a second. The last one is 6 times sine of 10. 1.04. So we have 2.57 I hat plus 3.06 j hat. They're both positive. Is that true for the second one? Are they both x and y's positive? No. They say positive, but where are we? Whoops. Where are we here? We're in the fourth quadrant. Y went down, so therefore it's minus 1.04 j hat. Do you see that? Y is down in the fourth quadrant, so we are negative. Sign's negative there. Now, it says that I'm supposed to add these together, so I'm going to add them together. So I'm going to use the exact same steps as before, adding the i's together, adding the j's together. So 2.57 plus 5.91, that'd be my I hats, plus 3.06 plus a negative 1.04, that'd be my j hats. So 7, so that'd be 8 what? 8.48 I hat. And I think it still stays positive, plus 2.02 j hat. Now, we have two options. Guys, this would equal running a positive 8 and up 2. So our point would be about here, 8.48 and a 2.02. So here's where I'm going to be. Yes? We can find r and we can find theta. Where would be the exact opposite direction of this? We have two options that we can have the equilibrium. This right now is the resultant. From here, if I said leave it in rectangular form, the resultant is backwards how far? Negative 8.48. Then, instead of going up, I go down 2.02. Homework is on page 209, 6 and 7. Have a great day.